students, greetings to all. In the earlier video lecture, we had discussed about matter. So whatever you see around you, whether it's this glass, this bottle or this jar having sugar, chalk or spoon, whatever you see around you is matter. So matter is anything that occupies space, it has got mass of its own, it can be felt and it offers resistance is what is referred to as matter. Through the activities today, we'll try to discuss what are the properties of matter. The first property of matter is that it is made up of particles. Next, the particles, they are very tiny in size. The third property, the particles of matter, they have got space between them. Fourth property, the particles of matter, they are continuously moving. Fifth, the particles of matter have a force of attraction between them. So they exert a force of attraction between them. Now we'll first try to understand the first activity, that matter is made up of tiny particles, or it is made up of particles. So matter is not, the particles are not continuous, but then they are particulate in form. So in order to understand that, we have taken a glass tumbler. 3/4 of the tumbler, the glass, I filled it with water. Now, I'll pour sugar in it, so I'll add a spoon of sugar to this solution of water. Now, what I'm adding is what is referred to as the solute. That means the sugar is the solute and water is the solvent. In chemistry lab, we use a glass rod for carrying out the process of stirring. We can take a beaker, 50 ml or 100 ml. If you take a 100 ml beaker, I can add 50 ml water to it and then a spoon of sugar or salt to it. And with the help of glass rod, but here with the help of spoon, I am carrying out the process of stirring so that sugar can get dissolved in water at a faster rate. Now when I am carrying out this process of stirring, I will see that the volume of water is not changing. That means the 3/4 of the glass was filled with water and it is the same. Though I keep on dissolving the sugar, it will get continuously dissolved in water. But then there will be no increase in volume of water. Now when there is no increase in volume of water, it shows that the particles of matter, they have space between them. That means the particles of water have space between them, into which the particles of sugar will get added up. Next, because we did not observe any change in this volume of water. The next thing is that how we'll come to know that whether sugar has been added, because after continuous stirring, I'll see that there are no sugar crystals. It has got dissolved in water right now because this is a unsaturated solution. So the sugar will get continuously dissolved. It will get completely dissolved in water. And how will I come to know that the sugar has been added up? If I taste this solution, the solution will be sugary in nature. I can use any other solute, like for example salt, so the water will become saline in nature. And therefore, by this activity, we deciphered the two properties of matter, that matter is made up of particles, and the next property, that particles of matter, they've got space between them, and therefore the solvent water, it incorporated the solute, that is sugar, into it. For the next activity, we are going to take 3 glasses, and 3/4 of the glasses, we'll fill them again with water. The next activity is so as to demonstrate that the matter is made up of particles, that is there, but then those particles, they are very tiny in size. So 3/4 of the glasses, I have filled it with water, and I'm going to add 2 to 3 drops of ink to the water. through the corners. So at the edges, so at just placing the ink at one corner, I have added 4-5 drops of ink to the water. Now as I've added this ink, I had added it along the just along the borderline, and now you can see that the whole solution, it has turned blue in color, purplish blue in color. So now this whole solution, it got turned, it got colored up. The reason being that the ink that is made up of dye dissolved in water, it got mixed up in water, it got readily diffused in water. So that means it is made up of particles and there are space, and therefore it got diffused. Now if I stir it for concomitant for proper mixing, even distribution, and if I add 2 to 3 drops of this water to the other beaker, I'll again see that, so I've added 3-4 spoons over here, and I'll again see that the other solution also turned bluish purplish in color. Now the intensity will keep on decreasing as I'll keep on adding the solution. That means that 4-5 drops of ink, it has got many tiny particles. It is made up of n number of tiny particles of matter, and therefore they had the capacity to color the solution even on carrying out continuous dilution. So here when we talk about the process of diffusion, now see, ink got diffused very readily, but then it depends upon the substances which are used. Now liquid, like for example, if I take it to be honey, and if I add it from one corner, then I'll see that it will not get that readily diffused as the ink got. Now the reason, because honey, so you can see it has not got diffused very evenly, right? The reason being because honey is a viscous liquid. That means viscosity is the resistance to the flow, right? So we can see that the honey is not getting very evenly distributed like the ink. Now, in order to understand this concept of diffusion, we can take the example of an incense stick. Now, that is generally in the puja room, we light the incense stick. Now, if I light this incense stick, I'll see that the fumes will be produced. And now these fumes, they'll get diffused. So you can see that the fumes, they are getting evolved, and these fumes, they'll get traveled, they'll mix up. Now because it is, as I said, matter is particulate in nature, and these particles of matter, they are continuously moving. So we can see that these fumes, they are getting mixed, intermixed with the particles of matter present in the air, and we can smell the smell of this, we can get the smell of this incense stick. Though we'll be there in some other room, we are not there in the puja room, but we'll be able to get the smell. The similar is the concept of the deodorants or the perfume which we apply on the body. They get diffused. That is the property of matter, which states that. And when we talk about gaseous particle, yes, because they are the interparticle distance is very high, so therefore they'll diffuse readily in comparison to liquids and solid. Now talking about the last property of matter, that matter, the particles of matter, they've got force of attraction between them. So in order to understand this activity, we'll take a piece of chalk, that is calcium carbonate, CaCO3. Made up of calcium carbonate, we'll take a rubber band and we'll take an iron nail. In order to understand this, we'll have to break these articles, these solid, by either hammering or by offering physical force. So I'll apply some physical force, and when I apply a physical force and try to break this piece of chalk, yes, I'll be very easily able to break the piece of chalk. The reason being, the force of attraction is less in comparison to the rubber band and the iron nail. Now, this rubber band is elastic in nature, so it can stretch. And if I keep on continuously applying greater force, I'll be able to break this rubber band. But when I talk about this other solid, that is the iron nail, it will not be possible for me to break this iron nail with the application of force. So all of them are solid, but then the particles of matter, they are held together with a high force of attraction in case of solid like iron nail, then in case of rubber band, and then a piece of chalk. So through these activities which we conducted today, we tried to garner the concepts related to the properties of matter very thoroughly, that matter is made up of particles which are very tiny, they diffuse readily, they've got force of attraction between them, and there is no change in volume. That means they've got space between them. So in this module, we have tried to understand the properties of matter. Thank you, one and all.